let's say you want to know how big a snowflake is, and all you can see are the sparkles in the snow. So, within a certain area, you see a certain amount of sparkles. But let's do this in one dimension, really, um, just because it'll make the math easier. So what we need to know is, okay, so from the side point of view, what this looks like is um, kind of like each snowflake is next to each other snowflake, and we're just going to assume every snowflake is about the same size. And what we want to know is well, the first thing we want to know is what's the average spacing, how much space each snowflake takes up, right? Because if it's at a sharp angle, that's not going to take as much space as if it's a flat angle. And then once we can take that into account, then we'll know how many snowflakes we have per, unit length. And okay, so in order to do that, we're going to need two things. We're going to need to know the probability of a snowflake being at a certain angle. Oh, I'm doing this backwards from your point of view. Those were still the same. Okay, so we need to know the probability of a snowflake being a certain angle, and then how each angle affects the amount of space it takes up. All right, so, well, I guess, okay, so we got to do the trig. Let's do the trig over here. So this part's pretty straightforward. You can just draw a circle. Let's make this little. Oops. And so let's make a theta. Oh no. Okay. Let's make a theta right here. So let's say this is the snowflake. Then we want to know the angle of the snowflake compared. And if you follow the angles around, that also happens to be this snowflake, this angle right here, right? Because you can imagine that if the snowflake went all the way flat, this angle would kind of go to 0 and this one would go to 0. So yeah. And we need to know, or sorry, so then that tells us this right here. So if the length of a regular snowflake is L, then this air part right here, we'll call that S. And I'm doing this backwards again from your point of view. Oh, geez, won't work. Okay, there we go. So this part right here is S. L looks the same basically. Okay. And yeah, so then you do a little trig and it's basically man, L's are hard backwards. L cosine theta is equal to S. Okay. So then the other tricky part is what's the probability, right? Well, that's kind of simple. That's just the d theta over the 2 pi. So in other words, d theta is, your chances of landing in this tiny, infinitesimal area. And then 2 pi is divided by the whole side. So that's kind of the probability of landing, like if you have 10 marbles and one of them's red, then, your chances of getting that red marble divided by the total number of marbles. So now we have everything we really need to calculate the average length. So that will be S bar, average length, is equal to, so we got the probability, which we said was d, I'm doing backwards again, d theta, oh man, backwards, d theta, there we go, over 2 pi, and then we have the cosine of theta. And we want to integrate that between negative pi over 2 and pi over 2. And where did I get these numbers? Actually, these twos are backwards from your point of view. Sorry, 1 second. Pi over 2 negative pi over 2. So where did you get these numbers from? That's basically we're integrating from the snowflake looking like this, where it's pointing in this direction, and then all the way here. So that's, that's the part we care about. Okay, so fortunately this gives us a simple thing to, oh, and I forgot one piece. So I said cosine theta, but that actually should be, I used L. Yeah, L is the length of the snowflake. So, yeah, so there we go, now we're ready. And so yeah, this part's easy. So we know that sines get derivatized into cosines. So and that's what we have here. We have a cosine, and we have cosine d theta, which makes it easier. So then basically if we're going backwards, we're going to sine. So we get, switch pens because now we're in derivative land. We have sine back, okay, sine theta. And we have a few constants. We have this L and the 2 pi. So I'm going to move those out here. L and the 2 pi. And okay, we've got everything that matters. Okay, and then we are evaluating this at our two endpoints, so the pi over 2 and the negative pi over 2. And is, well, sine pi over 2 is just 1, and then minus, the other one, and then sine negative pi over 2 is negative 1. And so basically we just have 2 down here. And that cancels out with this 2 right here. And so we are left with, I'm going to write it over here. We are left with the average length, and that is equal to, it's just L over pi. Yeah. Okay, so now that we know the average length, we can compare this to the how many sparkles we see. Well, really, how many snowflakes there are per, you know, unit length. We'll just pick a length. We'll call that capital L. And so if we see, or if there should be n snowflakes for a certain length, and then S bar. So in other words, if you divide the total length by the average length of each snowflake, that tells you how many snowflakes there are. Now the thing is, well, I guess we can plug this in right now just to simplify things. So plugging this in, L's underneath, so we get a pi, and we get the L length of the snowflake there. Okay. So this part we need to kind of do a little bit of thinking. So I guess we'll go over here. So we got our unit circle again, and we got the substance, the sample, and let's say that your pupil, right, like how many sparkles you're going to see depends on how big your pupils are. And let's say that out of all of our, our pupil size compared to how far we are away from the sample, let's say that takes up about 1 degree. So 1 degree is, 180th or 1/360th of the circle, which means that because we're only seeing, 1 degree out of the 360, that means that only 1 out of 360 of percentage or whatever you call it, that fraction of all the snowflakes that we can that of all things we see are the snowflakes that are pointing at us. Those are the sparkles. So in other words, if we take this number here and we call this the if that's the total number of them, but we're only seeing the 1/360th of them because that's the numbers that are sparkling. Basically, that's how many sparkles you're seeing per unit length. Then we just have to take this number and divide it by 360. And this is the hardest part of doing backwards. 3. Okay, so it's a normal 6. 360. There you go. So I'm just gonna use this, so I'm gonna rewrite everything right here. Hopefully this looks right from your point of view. So yeah, so we got number of sparkles is equal to pi L, which is the unit length, and you can just, basically what you're saying is how many sparkles do I see in a certain length, and then, which, this is a number that you count, this is a number that you measure, pi over 360, and then that will tell you the length of a snowflake. And that is how you find the length of a snowflake, by how many sparkles you're seeing.